Okay, number 1, use factoring to solve the quadratic equation. Check by substitution or by using a graphing utility and identifying x-intercepts. So we've got, and I'll write this on the side, we've got x squared minus x minus 56 equals 0. So if we're going to factor this, it is a trinomial, so we're going to start off with our two parentheses, and the first thing in both those parentheses is going to need to multiply to be x squared. That's easy enough. It's going to be x, and the last two things in both those parentheses, that and that, are going to need to multiply to be 56, and we also want them to add to be -1. Two factors of 56, 7, and 8, we could get -1, get them to add to -1 if the 8 is negative and the 7 is positive. From there, anytime we're multiplying two parentheses and we're getting a product of 0, one of those parentheses has to be 0. So either x plus 7 equals 0 or x minus 8 equals 0, and we'll solve both of those. Subtract 7 on both sides and we get x equals -7. That's one of our solutions. And on the right, add 8 to both sides and we get x equals 8. Okay, number 2, we've got 1 over x plus 1 plus 5 equals 11 over x plus 1. Anytime you've got an equation with a bunch of fractions, the easiest thing to do is to get rid of those fractions by multiplying by a common denominator. And the common denominator, in this case, since we've got x plus 1 is a denominator in the first term, 1 is a denominator in the second term, and x plus 1 is a denominator in the third term. So the common denominator for all of those is x plus 1. So we're going to go ahead and use that and multiply every single term by that. So we've got x plus 1, multiplying that on the first term, x plus 1, multiplying that times 5, and then x plus 1, multiplying it times the last one. And some nice things happen there. We get some things that cancel. The x plus 1 on top and bottom cancels there. And on this last term, x plus 1 cancels there. Now we've got, for the first term, just 1 left. And then we've got plus 5 times x plus 1. And equals, and we just had 11 on the other side. If we distribute the 5, we get 1 plus 5x plus 5 equals 11. Add our two like terms. We got 6 plus 5x equals 11. Subtract 6 from both sides. We get 5x equals 5. And then divide both sides by 5. Get x equals 1. And anytime you have fractions with variables in the denominator, like we do here, x plus 1, we're going to have a restriction, something that x can't be. So x cannot be, in this case, -1. If x is -1, we've got a denominator of 0 and therefore an undefined equation, and we can't have that. So as long as our answer is not -1, and it's not, we're okay. Okay, number 3, the average cost of tuition and fees at public 4-year colleges in the United States can be modeled by the following formula, where T represents the average cost of tuition and fees for the school year ending X years after 1996. When will tuition and fees at public U.S. colleges average $4,586? So this T in that equation, T equals 165x plus 2771, T represents the tuition and fees. So it's asking, when will that be 4586? So if we go ahead and plug in 4586 for T, and then equal to 165x plus 2771, and we just solve for x. So that's all we'll need to do. Plug that in and solve for x. So we'll want to get the x term by itself, so we'll subtract 2771. Bring down our equal sign. On the right, we've got 165x, and let's see what we get. 4586 minus 2771 equals 1815. And to get that x by itself, we'll divide both sides by 165. So we get x equals 11. So we'll need to be careful because this is the number of years after 1996. So we'll want to go ahead and add 11 years to 1996. So be careful not to put 11 in the answer. You're just going to put in 2007. Okay, 8 plus 4i in parentheses minus 9 minus 3i. So we're subtracting the second pair of parentheses. And be careful you don't distribute here because it may look like we're multiplying these two parentheses, but that minus in the middle shows us that we're not multiplying these, so we won't want to do any sort of distribution. So we're going to, let's go back. Eight plus 4i, and we're subtracting everything in that second parentheses. So we're subtracting 9. We're also subtracting negative 3i. And when you subtract a negative, that's the same as adding 3i. Then from there, we're just putting like terms together. 4i and the 3i and the 8 and the negative 9. 8 and negative 9 gives us negative 1. 4i and positive 3i. We put those together just like regular variables, even though it's a complex imaginary number. And as long as the I term is second, this answer is fine. This is in that A plus BI form. Okay, solve the linear equation 5x plus 7 equals 2x plus 55. This one's fairly straightforward. 5x plus 7 equals 2x plus 55. So we'll want to get the x's on the same side, so you can do that however you want. I would move the 2x to the left side of the equation. And in order to do that, we've got to turn it into 0. So 2x, if we subtract 2x, that becomes 0. And we'll have to subtract 2x from both sides. So we get 3x now plus 7 on the left equals 55. And we want to continue getting that x term by itself. So we'll subtract 7. Bring down the equal side. We've got 3x equals 55 minus 7, which is 48. Divide both sides by 3. And we get x equals 16. Okay, so the solution set would go in A. The solution set is 16. We talked about in class, a solution set is x, where x is a real number. If you're in a situation where all the x's disappear and you have only numbers left, maybe something like 5 equals 5, that would be a true statement, and it would indicate that anything that we plug in for x is going to work. So as long as x is a real number, and you get 5 equals 5, that would go there. If the x's disappear and you end up with something like 5 equals 4, that is a false statement, and that would go here, indicating that there's no solution. There's nothing that we can plug in for x that would make this work. Next up, number 6, we've got 9 plus 2i times 9 minus 2i. These are conjugates, by the way, which means they're just the same, but they've got a different sign in the middle. We're just going to go ahead and solve this like we might normally solve a pair of binomials being multiplied. Just distribute the 9 to both the other two terms, and we're going to distribute the 2i to both the other terms. So 9 times 9 is 81. 9 times negative 2i is negative 18i. 2i times 9 is positive 18i. And then the 2i times negative 2i is going to be a negative 4. And then since we're multiplying i's there, it's going to be I squared. Make sure you guys remember, anytime you have I squared, you're going to replace that with negative 1. I squared is equal to negative 1. So this is really 4 times negative 1. So we've got, and another thing that happens with the i's, negative 18i and positive 18i cancel. And we've got 81 minus 4 times negative 1, which we said I squared is. So in other words, 81 plus 4, which equals 85. Okay, number 7, 3x minus 8 is greater than or equal to 7. So we want to do some work to get x by itself. Start out by adding 8 to both sides. That'll get the 3x by itself. Make sure you bring down your inequality. 7 plus 8 gives us 15. Divide both sides by 3. And we've got x is greater than or equal to 5. So not only are we solving this inequality, so that would go there, we're also looking for the graph that goes with it. So let's do this in pink here. So we're saying x is greater than or equal to 5. So if we're looking at our number line, we've got 5, we've also got 6, 7, all the things that are greater than 5. And I'll highlight all those things that are greater than 5. We want to make sure to highlight those, and anytime it's greater than or equal to, we're going to use a bracket at 5, just to indicate that it could be 5. If it were x is greater than 5, we'd just be using a parentheses at 5 and then highlighting everything greater than 5 from there. So this one is actually going to be B. Okay, number 8, x squared plus 10x plus 21 equals 0. It says solve the following equation using the quadratic formula. Okay, so if we're using the quadratic formula, we'll need to know, well, first off, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. And you'll be given that for the test, so you don't need to worry about memorizing that necessarily. But we will want to identify what A, B, and C are if we're going to be plugging those things in to the formula. A is going to be whatever is in front of the squared term. So A, in this case, is going to be 1. B is going to be whatever is in front of the variable term, which is positive 10. And C is going to be whatever the constant is. And since we have plus 21 there, our constant is 21. So that's our A, B, and C. Just going to plug those into the formula. So we've got negative B, which a minus in front of B, plus or minus the square root of b squared, which is 10 times 10, or 100, minus 4 times a, which is 1, times c, which is 21. Try to fit that in there. All over 2 times a, which is 1. Okay, so going a little bit further, we've got, that should be 21 there. Negative 10 plus or minus, we've got 100 minus 4 times 1 times 21 ends up being 84 over 2 times 1, which is 2. A 100 minus 84 is 16 over 2. Negative 10 plus or minus the square root of 16 is just 4 over 2. And you might note that negative 10 and positive 4 are like terms, and negative 10 and negative 4 are like terms. So we could combine those into one term. I'm going to do that down here. Negative 10 plus 4 over 2, and then negative 10 minus 4 over 2. And we should get two distinct answers. Okay, negative 10 plus 4 is negative 6 over 2, which is negative 3. And negative 10 minus 4 is 7, or negative 14 over 2, which is negative 7. Okay, so we end up with two different answers there, negative 3 and negative 7. Okay, number 9. According to statistics, a person will devote 36 years to sleeping and watching TV. The number of years sleeping will exceed the number of years watching TV by 18. Over the lifetime, how many years will a person spend on each of these activities? So they basically give us two sentences describing this situation. We know that sleeping and watching TV, if we were to add those together, they're going to total 36 total years. We get that from the first sentence. And then the second sentence, they tell us that the number of years sleeping will exceed the number of years watching TV by 18. So we can tell that sleeping is something it's larger than watching TV. So we could say that sleeping is equal to watching TV plus 18 years. Or you could also write S minus 18 equals W. Either way would work. Once you've got those two equations, then what we can do is solve by substitution. If you look at the equations individually, we can't solve this top one, S plus W equals 36, because we've got two different variables. We can't solve the bottom one because we've got two different variables also. But if we could substitute this W plus 18 in for S up top, since we know S is equal to that, then we could solve it. So instead of that S plus W, we'll replace S and then write the rest of that equation. So W plus 18 plus W equals 36, and then we'll solve that, put the W's together. We've got 2W plus 18 equals 36, subtract 18. 2W equals 18, divide by 2, W equals 9. Okay, so if W equals 9, and we know that S equals W plus 18, then S must equal 9, which is W, plus 18, which equals 27. So S is equal to 27, and W is equal to 9. Okay, number 10, 3x squared plus 1 equals 244, and it says solve by the square root property. There are other ways to solve this. We could use the quadratic formula. But here they're asking us to use the square root property. So if we want to use the square root property, we want to isolate the squared term, which is the 3x squared, and we want to get the x squared by itself. So the first thing we do is we subtract 1 from both sides. We've got 3x squared on the left, and then 244 minus 1, 243. Still want to get that squared term by itself, so need to get rid of that 3. So we'll divide both sides by 3. And x squared equals 81. And this time we want to get rid of the 2 because we want to know just what x is and not x squared. So in order to do that, we can get rid of that 2 if we square root the left. And that will get rid of the 2 and the square root, but we'll have to square root the right also. Keep in mind, our answer is going to be x equals I'll put this in blue, plus or minus whatever the square root of 81 is. The square root of 81 ends up being 9, so we've got two different answers here, 9 and positive 9, or negative 9 rather. Number 11, find the real solutions of the equation. The square root of 5 minus 4x equals x. And this one we'll just want to make sure to check our answers. Since we don't want a square root equal to a negative number. X, oops, let's say this a different way. The square root cannot be equal to a negative number. So if we plug x back in this case, x is just by itself. So if x is negative, that won't work. So that answer we throw away. Up here, we've got the square root of 5 minus 4x equals x. So just to start off, we want to get rid of the radical, and we can do that if we square both sides. Okay? The square root and the 2 negate each other, and we're just left with the 5 minus 4x equals x squared. And then you have to make a decision how to solve it. It is a quadratic equation since it's got a squared term. So you could set it equal to 0. Let's shrink that. I guess we can't do that. Set it equal to 0. So we might add 4x and then subtract 5 from both sides. Add 4x. Subtract 5. Then we've got 0 on the left equals x squared plus 4x minus 5. And then you can solve that either with the quadratic formula or you can just solve by factoring, which if you can solve by factoring, that's usually the way that you want to go just because it's a little bit quicker. We know we'd have x and x, and the two things on the end there have to multiply to be 5. That's definitely going to be 5 and 1. And we can make positive 4, this middle term, if the 5 is positive and the 1 is negative. Okay? And then from there, anytime you've got the two parentheses multiplying to equal 0, one of them has to be 0. Either x, either x plus 5 equals 0 or x minus 1 equals 0. Subtract 5 from both sides, x equals negative 5 or x equals 1. And for this one, with these equations with radicals, make sure you check your answers. If we were to plug in negative 5 for x, we would get the square root of 5 minus 4 times negative 5 equals negative 5. And we cannot do that. Our square root has to be positive. That's the one that we're looking for. So it can't be equal to this negative over here. So this is what rules it out. X cannot be negative 5. But if we put the 1 in there, 1 is okay. Okay, 6x to the 5 halves minus 30 equals 0. This is number 12. And we've got a fraction exponent here, this x to the 5 halves power. So what we'll want to do is isolate that fraction exponent. So just to start off, we will move this 30 over, so we'll add 30 to both sides, bring down the equal sign on the left. Now we've got 6x to the 5 halves power equals 30. And we got to do a little bit more work to get that x by itself. So going to divide both sides by 6. X to the 5 halves equals 30 divided by 6, which is 5. And we just want to find x, so we've got to get rid of that 5 halves exponent. And the way that we do that is we're just going to raise this x to the 5 halves to the 2 fifths power, which is just the reciprocal of 5 halves. And so if we raise that side to 2 fifths, we've also got to raise the right side to 2 fifths also. So on the left, the 5 and the 5 cancel, the 2 and the 2 cancel, and we're just left with x to the first equals 5 to the 2 fifths power. Number 13, solve the quadratic equation by completing the square. And you might remember when we're completing the square, we're going to take the number in front of the variable term, that 4, and we're going to have it, then square it. So half of 4 is 2. And then when we square 2, we get the number 4. So we're going to add 4 to both sides. So this is going to be x squared minus 4x. And then we are adding 4. That's going to complete the square, equals 6. And then we've got to add 4 there also. If we add 4 to the left, we've got to add 4 to the right also. And the way this is going to help out is because if we wanted to factor this trinomial on the left, put our 2 parentheses, we've got 10 on the right side. So on the left, we've got x and x when we factor it, and we need 2 things that multiply to make this 4 here, and that will add to give us negative 4. So that would be negative 2 and negative 2. And you might notice those are identical, so we could write this as x minus 2 and then square it equals 10. And then to solve it from there, we could use the square root property and get rid of that 2 by square rooting the left and also square rooting the right. So the 2 is going to cancel out, and so is the square root on the left, leaving us with x minus 2 equals, and anytime we use the square root property, we got to do that plus or minus the square root of 10. Okay, from there, we got to go a little bit further because we need to get the x by itself, so we're going to add 2 to both sides. So we'll end up with x equals 2 plus or minus the square root of 10. Number 14, solve the formula for c. And we've got 1 over s plus 1 over k equals 1 over c. We talked about something similar to this. We've got an equation with fractions. And when we've got that, what we want to do is, these problems are much easier to solve if we can get rid of the fractions. And the way that we do that is to multiply the common denominator times everything. In this case, we need something that s goes into, something that k goes into, and also something that c goes into. And our common denominator is going to be skc. S goes into that denominator, k goes into that, and also c goes into that. So we're going to take that times every single one of these terms. skc, 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 and some things are going to reduce. The s's here are going to cancel, the k's here are going to cancel, and the c's are going to cancel. And we should be left with an equation that doesn't have any fractions. So up top, that leaves 1 times kc, which is just kc, plus 1 times sc, which is just sc, equals 1 times sk, which is just sk. Okay? And ultimately, we want to get c all by itself. And the way that we're going to do that, since we have 2 c's, you might notice that we could factor out a c out of this expression on the left. And if we do that, if we take the c out and then rewrite it, that c out of that first term leaves a k, and c out of the second term leaves an s, still equal to sk. Now we can get c all by itself if we divide by k plus s. So divide the left by k plus s, and that's going to cancel out those two, and then divide the right by the same thing. Kind of funky looking, but that's the answer. 1 plus 6i over 2 plus 4i. Here we are wanting to get rid of this I in the denominator, and the way that we're going to do that is we're going to multiply by the conjugate, and the conjugate just looks the same as the denominator. It's only got a different sign in the middle. So instead of 2 plus 4i, 2 minus 4i. We're going to multiply that times the bottom, and if we multiply the bottom times it, we've also got to multiply the top times the same thing. Okay, so when we distribute on top, we're going to take the 1 times the 2, and then the 1 times the negative 4i, and we're going to distribute the 6 also. The 6i to the 2, and then the 6i to the negative 4i. Afterwards, we're going to distribute the 2 on bottom to both of those, and then do the same thing with the 4i. So starting up top, we've got the 1 times the 2, gives us 2. 1 times negative 4i gives us negative 4i. Then moving on to the 6i times 2. And then the 6i times the negative 4i. Negative 4i squared. And keep in mind, anytime we see one of those I squareds, we're going to ultimately replace it with negative 1. Okay, so that takes care of our 2 binomials on top. On bottom, distributing the 2. 2 times 2, 4. 2 times negative 4i, negative 8i. And then distributing the 4i times the 2, and then the 4i times the negative 4. So 4i times the 2 is going to be positive 8i, and then the 4i times negative 4i is going to be negative 16i squared. So we've got a couple I squareds there, and we're going to keep in mind that that's actually negative 1. So not subtracting 1, but multiplying 1, so maybe I'll put that in parentheses. We're multiplying negative 1 on those ones. So we've got now some like terms there. We've got 2 plus 8i. And then negative 24 times negative 1 is positive 24. On bottom, the negative 8i and the positive 8i, those cancel out. So now we've got 4, and then the negative 16 times negative 1, that makes a positive 16. So that's going to be equal to, we've got some like terms there, 24 and 2 makes 26 plus 8i over 20. And that's just about done, only that we want to put it in standard form. So let's use a different color for that. So what we'll need to do is split this up into 2 fractions. Instead of 26 plus 8i, we'll do the 26 over the 20 plus the 8i over the 20. Okay, both of those can reduce. 26 over 20. Those reduce by 2, and we've got 13 over 10 plus the second fraction reduces by 4. So we've got 2 over 5i, and ultimately that's as far as that we can reduce that. Okay, number 16. 9 is less than or equal to the absolute value of 3x minus 9. So you don't necessarily need to go through this sort of process of writing this out. But basically what we're saying is that the distance from 0 is greater than or equal to 9. So if we've got 0 and we've got 9, we're saying, and also negative 9, we're saying that the distance from 0 of that is greater than or equal to. So the only areas where the distance from 0 is greater than is either those 2 points. So at negative 10, it's greater than 9. At positive 10, it's greater than 9. We're also saying that negative 9 and 9 could also be the things that are inside that absolute value. So one way to write this is to say that 9 is less than or equal to 3x minus 9. And here we're not using absolute value signs. And that is less than negative 9. So we're going to end up with both sides of this number line represented here. So what we'll do is we'll solve for x, add 9 to all 3 sides of this. Now we've got 3x in the middle. And then we'll divide both sides by 3. So we've got x in the middle, less than or equal to 0. 0 divided by 3 is just 0. It's greater than 18 divided by 3, which is 6. So we're saying, on the one hand, that x is greater than or equal to 6, and also that x is less than or equal to 0. So if we were writing this in interval notation, which is what it's wanting here, you might start out by writing a number line, and we're saying x is greater than or equal to 0. So if we put 0 on there, and then we're actually saying it's less than 0. So we're going to face all the things that are less than 0. And it should look like that. And then also at 6, we're saying it's greater than 6. So we're going to face all the things that are greater than 6. And then highlight that. If you make a number line, it makes the interval notation a lot easier to do. So the interval notation here, it goes from negative infinity, and we always use a parentheses at negative infinity, or positive infinity even, all the way up to 0, and we use a bracket there. Okay? And then we're going to combine this set with the other set, 6 to all the way up to positive infinity. So at 6, we've got a bracket because it could be 6, since we've got greater than or equal to, all the way up to infinity, and we use a parentheses at infinity. So that's our interval notation. Next up, number 17, use the graph to the right to complete the following. For the graph, tick marks along the axes represent 1 unit each. So A, determine the x-intercepts. So the x-intercepts, those are going to be the spots where it intercepts the x-axis. So let's zoom in a little bit here. So the x-axis, or the x-intercepts rather, are going to be that point right there. Let's use pink. That point right there where it intercepts the x-axis, and also that point there where it crosses the x-axis. So you just need to know what those points are. We always do x and y when we're picking out coordinates. So if we do the one to the left, that one there is going to be -1 is the x value, and then it's not up or down, so it's 0. And then this point is +3, comma, 0. So easy enough with the x-intercepts. If, let's see here. If we wanted to look at the y-intercepts, we'd be looking at where the graph crosses the y-axis. And that would be at this point here. Let's use a different color. That point there, and it doesn't look like it crosses the y-axis anywhere else. So we just want to figure out what that point is, and it looks like it's on the x-axis. It goes over 0, but then it goes up 1, 2, 3, 4, 5, 6, 9, and that's our y-intercept. Number 18, on 2 examinations, you have grades of 84 and 87. There's an optional final exam, which counts as 1 grade. You can decide to take the final in order to get a course grade of an A, meaning a final average of 90. What must you get on the final to earn an A in the course? So typically, when we're figuring out averages, we add the scores that we've got and then divide by the number of inputs. So we've got an 84 to start with, and then we're also adding an 87. If we were to stop there and figure out the average, we just divide by 2. But we are going to be adding a final grade, which we don't know what that is, so let's just call it X. And then ultimately, once we've got that grade, we're going to divide by 3, because now we'll have 3 tests. And we're hoping that this averages out to a 90. Okay? So if we can get this far at least, then all we've got to do is do a little bit of work to get that by itself. Let's shrink that a bit. Okay, so if we want to start to solve this, a couple of things that we can do. One, we could put our like terms together on top. And that would give us, what would that be? 1, carry the 1, 171 plus x over 3 equals 90. And then the next thing we could do, because we want to get the 171 plus x by itself, we could get rid of this 3 if we just multiply by 3. Since we're dividing by 3, if we multiply by 3, those two will cancel out. So now we've got 171 plus x by itself on the left equals 270. And then hopefully it's easy enough after that. Subtract 171, and that's going to get x by itself. So x equals 99. That's a pretty high score on the final to get an A. But that's what you'll need to get an A in the course. It goes on to say in B, by taking the final, if you do poorly, you might risk the B that you have in the course based on the first 2 exam grades. If your final average is less than 80, you will lose your B in the course. Describe the grades on the final that would cause this to happen. So we're basically saying what grades, if you got them, would be low enough that you wouldn't get an 80. So if we go back, let's backtrack a bit. And instead of 90, we make this 80. We're saying what do we need to get so that we have an average of 80. So still dealing with the same process. We've got 171 plus x over 3 now equals 80. So we're going to multiply 3 just like we did last time. 171 plus x equals 240. Okay, so on the first one, we found out that we needed to get a 99 to get an A, and to get a B, we've got to get at least a 69. So you'll lose your grade if you get less than a 69. Next up, find the solutions of the equation. This is number 19. The absolute value of 2x minus 3 is equal to 11. So if we think for a second about what that would need to be equal to, what inside those absolute value signs would make an absolute value of 11? Well, 2x minus 3, that number inside could be 11, since the absolute value of 11 is 11. We could also say that, let's do this in a different color. Two x minus 3 could also be negative 11. If we had negative 11 inside those absolute value signs, that would still give us an 11 absolute value. So we just need to solve both of these. That'll give us two different answers, and either one of them will work. So if we do a little bit of work to get x by itself, add 3 to both sides. Bring down your equal sign. We've got 2x equals 14. Divide both sides by 2. And you get x equals 7. Okay, if we plug 7 in, we get 14 minus 3, which is 11, so that works. And for this next one, add 3 to both sides. Bring down the equal sign. We've got 2x equals negative 8. Divide both sides by 2, and we get x equals negative 4. Okay. And that's actually our solution set. We have 7, comma, negative 4, or negative 4, comma, 7. Okay, number 20 says fill in the blanks so that the resulting statement is true. To solve x squared minus 4 fifths x equals 16 over 25 by completing the square, add blank to both sides of the equation. So keep in mind, whenever we're completing the square, if we've got the x terms on one side, and that's all we've got here, we've got the x squared and the negative 4 fifths x, what we're going to do is take that thing in front of x and halve it, then square it. So half of 4 fifths, all you have to do is take 4 fifths times 1/2 to halve it. That's going to give us 4 over 10. And then we want to square it. So we'll take that and square it, and that will give us 16 over 100. Okay? It says type an integer or a simplified fraction, so we do want to go a little bit further and reduce. So instead of 16 over 100, we're going to reduce that by 4. 4 goes into 16 4 times. 4 goes into 100 25 times. So this would actually be the number that we would add to both sides of equations. We'd add 4 over 25, add 4 over 25. We're not actually going to go through all those steps, but this is the number that we will be adding to both sides of the equation. Halve, then square that number in front of the x.